Okay, let's talk about one of my favorite and maybe one of the most misunderstood tools we have as programmers, assertions. Seriously, when you get these right, you can build some truly bulletproof software. But get them wrong? Well, you might just be writing fancier bugs.
You know the feeling, right? It's late, you get that alert, a production crash. So you scramble to pull up the logs, and what do you find? Nothing. Absolutely useless. It's a total black box. But what if? What if the bug could have just told you, right then and there, exactly where it was? Like, what if your code itself could point a giant flashing neon sign right at the problem? Well, that's pretty much what we're talking about with assertions.
So, what is an assertion really? Think of it like a tripwire you plant inside your own code. You're basically saying, hey, at this exact point, I am 100% certain that this variable is not null, or this list is absolutely positively sorted. And if you're wrong, if that condition isn't true, bam, the tripwire goes off, the program crashes. Now, that sounds bad, but it's actually fantastic. It's not a user-facing error. It's a loud, unmissable scream for help aimed directly at you, the developer, telling you that something you thought was impossible just happened.
Okay, so these tripwires come in two main flavors. First, you've got your debug assertions. We've probably all used these. They're on when we're developing and testing, but when you compile for production, poof, they're gone. Zero performance cost. But the real magic, and honestly where all the spicy debates happen, is with production assertions. These are the checks that you leave turned on, even when your code is out there running in the wild.
And to really get our heads around this, we're not just going to stick to theory. No, we're going to follow the actual journey of one developer, their multi-year saga of using assertions, fighting for them, and learning from them across different companies and languages. This story is pretty wild, actually. It spans from 2019 to 2025. It starts in the C++ world with the Swift compiler, then moves over to indexers for Ruby and Clang, and finally, a huge culture clash trying to bring assertions into Go at SourceGraph. We're talking big wins, some really tough failures, and a whole lot of lessons learned along the way. So, early in this journey back on the Swift compiler, an experiment was run. What's the actual performance cost of leaving most of these assertions enabled in a production build? The answer? A mere 3% increase in runtime. I mean, that's not zero for sure, but when you think about the potential for catching gnarly bugs, a 3% hit sounds pretty darn reasonable. Now here's where assertions went from being a nice-to-have to an absolute superpower. Imagine this. You have to debug crashes that are happening on your customers' machines, running against their private code that you can never, ever see. It's like being a detective with no clues. But with production assertions turned on, the crash report wasn't just a generic stack trace. It was a message that said, hey, I crashed because this specific invariant you promised me was broken. It was the one clue they needed to solve the case. But yeah, it wasn't all victories. When our developer tried to bring this whole assertion philosophy into the world of Go at SourceGraph, they hit a brick wall, a really big one. After a ton of discussion and a detailed proposal, the idea was basically soft rejected. It got labeled experimental, and if you've ever worked in a big tech company, you know that's code for, we don't really want to do this, but we'll let you play with it over in the corner. And here's the result of that experimental push. This chart tells the whole story. Our hero wrote 290 assertions. The rest of the team, combined, wrote 10. Yeah. It was a total failure in terms of adoption. But it was also an incredibly important lesson about how hard it is to change a team's culture and habits. Okay, so even though that last part was a struggle, all of this experience, the wins, the losses, all of it, led to some really deep insights. It uncovered a few assertion patterns that are, well, they're way more powerful than just checking for null. These are some next-level techniques. All right, so there are three big ones we're going to look at. First is monotonic construction. Sounds fancy, but it's simple. Say you're building a map from a list of items, you can assert that you never run into a duplicate key. It's a great way to prove your source data was clean. Second, database scanning. This is huge. When you're pulling data from your own database, not a third party's, you can assert things you know should be true. Like, for any row in the processed state, the processed_at column is never null. And finally, the one that's a real game changer, sometimes assertions. Okay, this one is just genius. A sometimes assertion is a special kind of check that you use in your tests. It doesn't just check a condition, it checks that across your entire test suite, that condition was seen to be true at least once and false at least once. Think about that. It guarantees that you have test coverage for both the if and the else parts of a branch. If someone later removes a test and breaks that coverage, your entire test suite fails. It's amazing. So how does this magic work? It's actually pretty clever. Conceptually, every time one of these assert sometimes functions gets hit during a test run, it just makes a note in some global registry, like a map. It says, hey, for key X, I just saw true. Then later, for key X, I just saw false. Then at the very, very end of the whole test run, a final check goes through that registry. If any key hasn't seen both true and false, the whole build fails. It's literally a safety net for your safety nets. And if you're thinking, that's a clever little trick, get this. It's not just a trick. It turns out that SQLite, one of the most widely deployed and battle-tested pieces of software on the planet, uses a very similar technique. That's probably not a coincidence, right? When the pros behind software that absolutely cannot be allowed to fail are using a certain pattern, we should all probably sit up and take notice. All right, so after that whole journey, what did we learn? What are the actual rules of the road here? How can you start using assertions in your own code effectively without, shooting yourself in the foot? Well, it all boils down to these 5 hard-won rules. Number 1, only assert things you are absolutely 100% sure about. 2, don't assert things about the external world. We'll get back to that one. 3, assert properties that your code downstream actually relies on. 4, for online systems, pair your assertions with some kind of coarse-grained recovery. And 5, make them dead simple to add and use. Okay, let's zoom in on rule number 2, because if you only remember one thing, make it this. Do not assert things about the external world. Assertions are for checking your logic, your code's internal promises. They are not for validating messy, unpredictable stuff, like user input, network data, or the return value from some third-party library. For all that stuff, you use proper error handling. You don't use an assertion that's going to crash your whole service just because an API returns some weird JSON. So let's say you're convinced. You're ready to start asserting. But now comes the real final boss, convincing your team. This can be the hardest battle of all, so let's get you prepared for the arguments you're definitely going to hear. And one of the biggest objections you'll face is a philosophical one, and it's summed up perfectly by the official Go language FAQ. The idea is that assertions are basically a crutch, a lazy way out that stops programmers from thinking deeply about proper error handling. This is a powerful argument, and you need to have a good answer for it. And here's the key to winning this debate, or really any technical debate. You have to separate the idealized culture from the real culture. In the ideal world, everyone reads every design doc carefully and arguments win purely on technical merit. But in the real world, people are busy, they skim, and old habits die hard. Your arguments need to work for the team you actually have, not the team you wish you had. So with that in mind, here's a little cheat sheet for the common objections. When they say performance, you come back with, most of these are super cheap, like array bounds checks, and we can put expensive ones behind a special flag. When they worry about risk, you say, we can mitigate that. We'll enable them gradually, starting with new code, and we'll add a runtime kill switch. Readability? They actually improve readability by making hidden assumptions obvious. And for the big one, philosophy, you hit them with the key distinction. Assertions are for programmer errors, bugs, not operational errors like bad input. They work with error handling, they don't replace it. So let's wrap this up with the big takeaway. Assertions are not a crutch. Far from it. They're a professional tool. They're a mark of discipline. It's about you, the developer, planting a flag in your code and saying, I guarantee this is true. It's how we build systems that are robust and, crucially, self-diagnosing. Systems that don't just fall over silently, but tell us exactly what went wrong. So I'll leave you with a question to take back to your own work. Think about the code you're writing right now. What's just one assumption, one little thing you know is true, that you could prove right now with an assertion? Give it some thought. Happy coding.